Okay, number 17, the table gives the polar coordinate r comma theta for four selected points, and which of the points lie in quadrant 2, a second quadrant of the xy plane. Okay, so you need to look at each point where it's located. So A, but remember we're looking for second quadrant. So let's say A is R is a positive, so that means that going into that direction. Negative pi over 4 is somewhere here, right? Negative pi over 4, and then R is a 2, so it follows that line, so it's like around here. Okay, that's quadrant 4, so eliminate. What about next one? Negative 3 pi over 4. So negative 3 pi over 4 is, here's a negative pi. So it's around here, right? That's a negative 3 pi over 4. And also positive. So it's located here, right? R is like that length, like that. So that's a quadrant 3. So it's not quadrant 2. Eliminate. Now, negative 2. So it's going opposite direction because R is a negative. 5 pi over 4, so little over pi, right? And then now going counterclockwise because this is a positive angle. So let's say this one, right? That's the same angle. Negative 3 pi over 4 or 5 pi over 4 is the same angle. But it's a negative, so it's going the other direction. It's right here. So located quadrant 1, so it's out. So answer has to be D, but let's look at one more time. Then theta is a 7 pi over 4. 7 pi over 4 same as here. The 7 pi over 4 is just going this way, right? Counterclockwise. But R is negative, so actually located the other side right here. So that's a quadrant 2, right? So answer is D. Now 18, the amount of water used each day in an office building measured in hundreds of gallons is modeled by the function g defined like this. Okay, it's a trigonometric function. For initial values of t is 0 to 365 days. Using actual data over time, it was determined that the model underestimated the amount of water used each day, 800 gallons. But remember, this is 100 gallons anyway. So, well, when you add 800 gallons or you subtract 800 gallons, you have to add only 8 or negative 8 because the unit is hundreds of gallons. Now, based on this information, which of the following functions is a better model for the amount of water used each day measured in hundreds of gallons? Okay, this they found that this actual model g of x is underestimate. So, this one you should move up 8 unit more, right? Because since it's underestimate. So what you have to do is your g of t, you have to add 8, okay, to cover up that underestimate. So then, let's say you're like whatever that function you have named, so different, like let's say f of t, example. Then g of t was this, so 5 sine 0.8 t plus 2, okay, and then plus 25, and then you add 8, right? Because to cover that underestimate, you should move up vertical translation by 8 unit up to be more exact. So then 25 plus 8 should be 33. So answer should be B then. Okay. 19. In the xy plane, two different angles alpha beta are standard position as shared terminal ray, and based on the information, which of the following gives the possible values for alpha and beta. So which one? So let's say example. In xy plane, negative pi over 4 is located here. That's alpha, right? That's alpha located here. Negative 7 pi over 4. So negative 2 pi is come back to here, right? So then, but negative 7 pi over 4 should be then around here, like that. So that's a beta. So they don't share terminal size, so eliminate. Okay. So if you keep going like that, Then let's look at C value. So let's see what happened. So alpha is a 3 pi over 5, which is like in the here, right? That's 3 pi over 5, and then located right here. Oh, that's actually B. So let's do C. But let's see like what's happening B. Then negative 3 pi over 5, then should be here, right? This way. So B also eliminated. So let's look at C then. 2 pi over 3. So that's located here, second quadrant. 2 pi over 3. So that's alpha. And then 8 pi over 3, which is this one, you can break it down. So 2 pi plus 2 pi over 3, right? Because 2 pi is a 6 pi over 3. So what does that mean? That means you go one more circle and then at the same terminal side, right? So the terminal rate is shares. So answer should be C. So they talk about same angle. And then you can check this also. It doesn't share the terminal rate. Number 20, xy plane. The function h is given by, okay, that exponential function. That is a horizontal translation of the exponential function. Okay, so that means a 2 unit to the left. F of x is a 3 to the x, and which of the following is an equivalent form of for h of x that express h as a vertical dilation. So dilation means either shrink or stretch, right? Okay, so let's manipulate the h of x. Then 3 to the x plus 2. So that means 3 to the x times 3 to the second power. So that means 3 second power is 9. So 9 times 3 to the x. So you can say f of x is 3 to the x, and then you multiply 9. That means it's a that's a translation. Vertical sorry, not translation. That's a dilation, vertical dilation by a factor of 9. So which is a vertical stretch basically. So this one vertical stretch, right? By a factor of 9. Okay, so answer is B. So you can look at same h of x. This one from f of x. You can say 2 unit left, translated to horizontal translation 2 unit left, or you can see as this one vertical stretch by a factor of 9. Then you should end up with the same graph. Okay. Number 21. The table gives values for polynomial function g as selected values of x, and then a is less than b. Then g of a is greater than g of b for all a and b in the interval 3 and 7. Which of the following could be true about the graph of g on the interval between 3 and 7? Okay, so I want to sketch it first this one by by hand. You can kind of sketch it quickly. So if you do, let's say here 3 is like negative 11 is around here. Let's say that's negative 11. Then 4 negative 19. So you go down 8 more. So let's say here negative 19. So somewhere here. Okay, now 5 negative 29. So here you subtract 8, and here subtract 10. Here, what is that, 41? So if you use a calculator, 41 minus 29, so you get negative 12. So here 55 minus 41, you get negative 14. So you see that there you go further down, right, every time. So it's like here, and 6 it's like here, 7 it's like here, right? So it goes further down. So we know that that's a concave down, right? And a decreasing and concave down. So which one? So it said concave up here, B and D you can eliminate. So clearly that's graph shape is concave down. Concave down means like this, and concave up is like that, right? So this one concave down and this one concave up. Okay, so let's look at A then. The graph of G is concave down because the function is decreasing. That's correct. And average rate of change over equal length input value intervals is increasing. What do you think? That one is not increasing, so that is a wrong description, right? So average rate of change means a slope. Slope is keep decreasing. That's why concave down. Okay, so answer is C. Okay. Now number 22, function f is given by another trigonometric function. The graph of f is mapped to the graph of g in the same xy plane by horizontal translation pi over 2 unit right. Okay, and which of the following is the expression for g of x then? Okay, so g of x it's pi over 2. So horizontal translate pi over 2 to the right means instead of x you substitute x minus pi over 2. Okay, that's what it meant. So when you substitute x minus pi over 2 instead of x, so 2 cosine pi and then parenthesis instead of x, x minus pi over 2 and plus 3. Okay, so you can put it on other parentheses right here. So which one looks like that? Then it should be B, right? So that's a horizontal translation. Number 23, the function C models temperature in degrees Celsius as a function of time. Okay. And the function P models electricity usage in kilowatts as a function of temperature in degrees Celsius. Let K be the composition of the function, composite function like that. And which of the following statement is true about the function K? Okay, what does that mean? This function K, your output is a P value. What was a P? P was a electric usage. But if you look at inside, very inside here, it depends on time, function of time in hours. So this K of T shows electric usage in kilowatts based on the time. Okay, that should be it. So models electric usage as a function of time. Yeah, A is a correct answer then, right? It's not function of temperature. It's not function of C. Okay, so you see that this one shows what is your independent variable. Independent variable is T, not C, right? K of T. So that's a function of time. Okay, and then K itself is a function of P. I mean the K itself is a function P, which is electric usage. So that's it models electric usage. Okay. Number 24, the figure shows the circle center at the origin with the angle measure theta radian. Okay. In standard position, the P is on the circle. Okay. Okay, that's a 5, 0. And the terminal ray of the angle intersect the circle at Q. The length of arc PQ is a 6. So right here, that's length 6. We know that length of an arc is r comma theta when theta is radian mode. Okay, so then if this one 6 and then r is clearly 5 here, so 5 comma theta. So we know that theta in radian mode 6/5. Okay, that's our angle. Now leave it like that, and then the which of the following gives the distance of point Q from y-axis? So what they ask you from point Q to the y-axis, so they ask you this distance right here. That's basically same as right here. Okay, that's also horizontal distance like that. So and then also this circle is radius 5, so this is 5. So you can say cosine theta is if you remember SOHCAHTOA. So cosine is adjacent over hypotenuse. Adjacent is, let's say mark it this on x. Then x/5, right? For that triangle. So cosine theta is adjacent over hypotenuse. So that's x over 5, and then you're looking for x. Okay, and so x is then 5 cosine theta. But remember, using that arc length, we found out theta is a 6 over 5 radians. So you just substitute here. So that x value is a 5 times cosine 6 over 5. Okay, so answer is C. Okay. Now in the xy plane, the graph of which of the following functions vertical asymptote at 3 pi over 4. Okay, regular cotangent, it cannot be, because a regular cotangent graph is, if you remember the basic cotangent graph, is up to pi, and graph looks like this, right? And then it passes through here, pi over 2. So that's a y cos cotangent x. So vertical asymptote is x equals a pi, not 3 pi over 4. That's why you can eliminate that one. Now, then what's the difference between those other answer choices? Then if you move, okay, let's say if you move here, the D, answer looks like a D. When you move, translate horizontally pi over 4 to the left, then what happened is here, pi over 4 is around here. So that's a negative pi over 4. If you shift it to the left, so right here, right? And then pi is 1 period. So negative pi over 4 plus a pi, which is a 3 pi over 4. So 3 pi over 4 located here, right? So that's a 3 pi over 4. And then your new graph of cotangent is like this, right? So that's a pi over 4 here. So that graph here, so since you shift to the left to pi over 4, now it used to be pi vertical asymptote, but now is a pi minus pi over 4, which is 3 pi over 4 is a vertical asymptote. Also, you can say negative pi over 4, right? So, but we are looking for 3 pi over 4. So answer, so it should be this one, right? All right, number 26. The function r is given by r of t. It's like that. And then which of the following is true about holes in the graph of r? So let's factor first the numerator, x minus 2, x plus 1. And denominator, x plus 1 square, x minus 2. Now you see that here, x minus 2, you have a same factor and same power, right? So that means that that's a location hole, right? But what about x plus 1? Is it whole? No, because they are different powers. So this is a power of 1, this is a power of 2. So actually, after you cancel out one of the x plus 1 on the numerator and denominator, you have only one x plus 1 left. And then at x equals to negative 1, there's a vertical asymptote then. Okay? So there's a no hole at x equals to negative 1. Only location of hole is x equals 2. So let's see. So it said holes are x minus 1. That is not true. So yeah, hole at this one only. That looks correct. And then, okay, let's see. The other one is, yeah, in the numerator, yeah, they are equal, not greater, right? The reason why only that one, it explains it here. 1 in the numerator is equal to the multiplicity of 1 in the denominator, right? And because of multiplicity 2 on the numerator is equal to the multiplicity 2 on the denominator. Okay, yeah, so that one then, if you think about the explanation here, then should be t here, right? So they are equal in the multiplicity, so that's why it's a whole here, right? And then, but x equals 2 is, I mean, x equals negative 1 is basically vertical asymptote. Okay, so yeah, that should be it. They should be equal, not, they should be equal to here. All right, 27. A regression model S is constructed for a data set. The residual from regression are plotted and labeled. Based on the vertical axis residual plot not shown, point A is located at 1.3, point B is located at negative 2.5. And which of the following statement is true about the model and estimate produced by the model that correspond to A and B? So let's just sketch it. So this is a residual, right? And then the point A is 1.3 positive. So this is a positive side here and this is a negative side. So let's say point A is like located here. So that residual is a 1.3, right? So that's a positive value. So that's a A. But B is further down. So let's say around here, right? So right here, that's a negative 2.5. Residual this time is a negative. So B is located here, right? So you can say, based on this graph, so you have to understand what is the residual first. Residual. So that's the difference between so real value, right? The correct value minus estimated. Okay, that's a definition of residual. So if residual is a positive, means your actual value is bigger than estimated. So that means you can say that's underestimated, right? That's why it's a positive. But if residual is a negative, that means your estimate is bigger than actual value, right? So that means it's overestimated. So you can say A is this one is since residual is a positive, so that's underestimated, and this residual is a negative. That means the estimated value is bigger, which is overestimated. Okay, overestimated like that. So if you look at the answer choices, should be underestimate at A, not this one, not this one, right? And then overestimate at B, so B and D is correct so far. And based on the absolute value, okay, well, absolute value, which one is further away from zero? So if it's a residual is zero, means that's exact, right? There's no error. But this is further down. That distance is bigger than this distance. So that means A is more exact, or you can say B is it has a greater error, right? So in that sense, let's see. So greater error with B than A, right? So should it be B? 27, answer is B. Now 28, there's a polar graph there. A portion of the graph of the polar function r equals f theta. F theta is, so this is r based on the angle. Okay, and then between A and B, and AB is between within 2 pi, and which of the following values A and B, okay? So let's analyze this graph, and you're not supposed to use a calculator, so you just plug it in by hand. When theta equals 0, cosine 0 is 1, so your r value, f of theta is r value. So 2 minus 4, cosine 0 is 1, right? So that's a negative 2. So you start from negative 2 when theta is 0. 0 is right here. And then negative r value, so going the other side. So you start from here. That's basically when theta equals 0, right? Now let's plug it in some other points. Let's say theta is like pi over 3, right? So when you plug in pi over 3, r is 2 minus 4. Cosine pi over 3 is 1/2, right? So 4 times 1/2 is 2. So 2 minus 2 is 0. Okay. So when theta is pi over 3, then it should be 0. So right here, right? So that's theta is pi over 3. So it looks like it going this way, right? So your A value, yeah. So then between A and B value, it graphs like that. So answer has to be A. you can double check. Let's say where's one more pi over 6, which is 30 degree located here. R is 2 minus 4 times cosine 30, which is a root 3 over 2. So 2 minus 2 root 3. That's a little negative value, right? Negative, I guess, like around 1.4, around there. So when 30 degree, right? 30 degree located around here, and then your R value is a negative, so going the other side. So I guess like around here, right? So yeah, that makes sense. It going this way then, right? So yeah, it follows that one. So that's correct. So which of the following values A and B? A value should be A, then B value should be pi over 3.